Hi there. We're going to take a look at some particle motion free response questions. Now, we've been working with particle motion, and now we're going to see how they kind of all fits together when we're looking at either an equation or a graph. And I think the questions that I have for this video are really going to help us to see what exactly the AP exam wants and the types of connections that we have to be able to make. Now, I'm going to preface all of that by saying this first question appeared in 2000 on the AB exam. Now, I did take part C off only because it is something that requires an antiderivative, and I only wanted this video to be about particle motion. So let's take a look and see what we have. We have two runners, A and B, who run for 0 to 10 seconds. The graph is two line segments. That's important. Shows the velocity. Looks like we're looking at the velocity graph for runner A. The velocity for runner B is given by this equation. So let's take a look at part A, which says to find the velocity of runner A and the velocity of runner B at time t equals 2 seconds, be sure to include units of measure. So we'll start with runner A. And runner A, it looks like for t equals 2 would be in this section right here. Okay. Now, instead of looking at that graph and trying to guess what that would be or approximate what that value is, we know this is a line segment. So we can write an equation for that line segment. In fact, that line segment has a y-intercept of 0. So this is going to be much, much easier. I can write an equation for this portion of the graph for A by doing the slope, which would be up 10, right 3. So my slope is 10 thirds, and my y-intercept would be 0. So now I can just simply plug in 2, and I'll get 10 thirds times 2, or 20 thirds for the velocity of runner A at time t equals 2. Be sure and include your units, which were meters per second. We were told that shows the velocity in meters per second there. Now let's do the same for runner B, but runner B, we have an equation to work from instead of a graph. So we're going to plug in 2 for the equation there. Oops, I'm going to put a 2 there. And so I've got 24 times 2 over 2 times 2 plus 3. So 24 times 2 would give me 48. And 2 times 2 would be 4, plus 3 would be 7. So I get 48 sevenths meters per second. Okay, so again, just a different approach, right? If you've seen any of my videos, you know a lot of times math questions are being asked in numerical, can you do it from a table, equation, graph, and words. And in this case, AP is trying to test whether you can do the analysis from a graph as well as an equation. So let's look at part B, which says find the acceleration of the runner, A, and the acceleration of runner B, and indicate the units of measure. So runner A, if we're looking at the velocity, then the acceleration is the slope. So the acceleration at 2 is the derivative or the slope of the velocity at 2. And the slope there, we did that when we wrote our equation for part 1, is 10 thirds. And my units there would be meters per second squared. Now let's do the same for runner B, but this time, again, we have an equation. So we're going to have to take our derivative, not as a slope, but instead by using the quotient rule. Okay, so you're going to do low, which is 2t plus 3. D high, that's the derivative of the top, which would be 24. minus the top, 24t, times the derivative of the bottom, which in this case would be 2, all over the denominator squared. Now let's clean it up a little bit because we are going to plug in the value of 2. So we'll distribute the 24. That'll give me 48t plus 72 minus 48t in my numerator. And that's still 2t plus 3 squared in the denominator. So notice your 48t's cancel, giving you 72 in the numerator. And now we're ready to plug in 2. Got 72 on top. Now, 2 times 2 is 4, plus 3 is 7, and we square it gives us 49. So we get 72 49ths meters per second squared. Now, let's turn our attention then to another problem. This came a couple of years later. This was in 2002 on the AP exam. And we're going to look at how a very similar question. We've talked about how particle motion a lot of times is a free response question. You're going to see this pattern of the different ways they ask it, but we can totally be ready for it by focusing on particle motion. So we've got an object that moves along an x-axis with an initial position of 2. I'm going to highlight that because I think that's pretty important. And the velocity is given by the function sine of pi over 3t. What is the acceleration? So the acceleration, remember, is the derivative of the velocity. So let's begin by taking the derivative. We'll have to use chain rule. So the derivative of sine is cosine. And then the derivative of pi over 3t is pi over 3. Now we're ready to plug in 4. And 4 pi over 3, I'm going to do a little sketch over here. 4 pi over 3 puts me in quadrant 3 with a 60-degree reference angle. Now, friends, I'll be real honest. I don't memorize those trig values. I don't know cosine 4 pi over 3 off the top of my head. Instead, I do what I just did, and that is to draw a triangle. I can easily figure out my cosine from there is negative 1/2. And so I get negative pi over 6. Now, for good measure, I'm going to go ahead and, well, I thought I was going to put units, but they don't have any units. Really hasn't indicated any units there. All right, now look at B. It says to consider the following statements. Statement 1, between this interval, the velocity is decreasing. And statement 2, the speed is decreasing. So let's see, are either or both of these statements correct? For each statement, please provide a reason why it is correct or not correct. Okay, so for the statement 1, let's test. In order for the velocity to be decreasing, its derivative, which would be the acceleration, must be negative. So let's test the acceleration in that interval. So I'm going to use the value of 4. Why did I use the value of 4? Because we just found the value of the acceleration at 4. So I know that it is negative. So the velocity is decreasing. Pretty simple if I use the values that I've done already before. Okay, now statement 2. Remember from our 5 commandments of particle motion that the speed is decreasing. Oh, by the way, if you have not seen my video on the 5 commandments of particle motion, you definitely want to do it. It's one not to miss. This makes it super simple. We know that the speed is decreasing when velocity and acceleration have different signs. So we already know that a of acceleration at 4 is negative. I need to know what the velocity at 4 is. So the velocity at 4, I'll need to plug that value in to the velocity equation. So that would be the sine of 4 pi over 3. Okay, now remember, I've already got my triangle for 4 pi over 3 drawn over here. The sine is negative square root of 3. So I know that it's negative. So I know that the acceleration and the velocity are both negative. That means speed is increasing. So let's say that in a sentence. Since acceleration at 4 and velocity at 4 are negative, the speed is increasing. And so let's just say statement 2 is incorrect. Okay, so I hope that helps with these particle motions. Go back and review the video that I did on the 5 commandments of particle motion if you haven't yet. It is a great one for especially if you're not a physics person. If you haven't had physics before and you're doing particle motion for the first time, those 5 statements I would have right beside me when I'm doing work on particle motion. It's going to become something that you learn and that you know, but have them right there with you while you're working problems, especially at the beginning. As always, please leave a comment if you have anything that I can help with. I would love the opportunity to do that. And you can always like and subscribe. That way you don't miss any videos that I post. So thanks so much. Bye.